I'm Steve Cooter with United Static Control Products. I'm the Director of Engineering, and today we're going to be demonstrating our new ESD brushes. We call them ElectraBrush. ESD brushes are used to remove particulate, dust, and contaminants. For example, there's a little hair on that beautiful Intel chip. We're going to brush it away. If you have little solder globs and that sort of thing, the brushes are good for removing those too, and just cleaning static-laden debris in general. It's important with an ESD brush that you're grounded. The reason being is an ESD brush is a two-way street for static. If the board has a static charge, it goes up the ESD brush fibers to the conductive handle, the static conductive handle, into your skin, and it's dissipated through either your heel grounders or, in this case, an ESD wrist strap. What makes a static control brush is the conductivity. It's important that the fibers are 100% conductive, static dissipative actually, and that they are unchanged by relative humidity. It's important that the handle has a certain amount of conductivity in it, and let's get into doing a little bit of a demonstration with it. Now with ElectraBrush, you'll notice each one of ours has a ESD emblem on it that shows that it's ESD. They're clearly marked with the ElectraBrush name and logo with our telephone number on them. ElectraBrushes are heat resistant up to 700 degrees Fahrenheit, making it perfect if you're doing a little bit of soldering. You let the solder cool, you can use your ElectraBrush to brush it off. The fibers are made out of a 12.6 nylon, so they're very, very robust. Unlike a lot of brushes, ESD brushes, ours do not contain horsehair. Insulative horsehair and other fibers are a no-no. It's important that all the bristles have a certain amount of conductivity, and ours do. So how do you know if an ESD brush is working? It's pretty tough. A lot of our competitors will actually use a document called ANSI STM 11.2. Now this document's great if you're in a lab and you have plenty of time to test your ESD brushes, because what you have to do is you have to basically acclimate them in an environmental test chamber for a day or two. They're tested at certain relative humidities. Okay? Minimum sample size is important because they're asking you for a sample size of a 3 inch by a 5 inch. That's really unacceptable, and nobody in the field can actually test a brush like that. So how do you know if they're working? All ESD brushes pretty much look the same. Here's two identical models. I'm going to take off my wrist strap because I don't like working with it today. Here's two identical brushes. This is your ElectraBrush. This is a standard brush that looks identical to it. Okay? What we're going to do is we're going to test the total conductivity of these brushes. Now this is something the ESD Association hasn't really delved into yet. They don't really have any procedures or tell you how often you need to test your brushes. But at any time a conductive fiber comes into contact with something as sensitive as a Intel chip, you have to be a little bit concerned. So you're going to want to test them. It's important to test them often. If you have this piece of test equipment and you have an ElectraBrush, it's pretty straightforward. Now here's a brush that is similar in looks to an ElectraBrush. We're going to hook a garment clamp up to it here. We're going to hook another garment clamp up to the bristles. And using this device, which is a megometer, we're going to shoot a 100-volt charge through the brush handle. Whoops, let me put that back on. I can do this all day long if it's not on a video. We're going to shoot a conductive charge through the ElectraBrush, or through this brush handle, into the fibers and see what kind of conductivity we're getting. Now something that's static conductive is less than 1.0 E06. That's 1 megohm in resistance. What we're looking for is a resistance level between 10 to the 6th and 10 to the 9th, which makes it static dissipative. I'm going to push the test button. And you'll see that this brush is coming in at 3.24 times 10 to the 10th. It's about as conductive as a piece of wood. Now, let's do the test with the ElectraBrush. Here we're going to go ahead and clip it on. We're going to attach it to the fibers. See if we can get a good pinch on it with our cables there. Whoops. Now we're going to run the charge through the ElectraBrush and through the ElectraBrush bristles and take the same reading at 100 volts. Here you're seeing a brush that's coming in substantially more conductive than the first variety. This is coming in at 4.43 times 10 to the 6th. So it has a little bit more than just 1 megohm in resistance to ground, making it a perfect substrate for getting rid of static electricity. Now if you have the facilities that has a meter similar to this, this is about $1,200 worth of test equipment here. We also have a cute little ElectraBrush tester that we came up with. That's this unit. This unit shows when you have a static charge. Plain and simple. I'm simply tapping my foot up and down, generating about 100 volts of static electricity. Okay, now when you test a typical brush, you can tap your foot as much as you want. And guess what? The little indicator's not going to light. Why? Because the charge isn't going from me into the test substrate. Now, let's try it with the ElectraBrush. Now you'll see me tap my foot up and down. I don't know if you can hear that on the video, but I'm just tapping my foot. I'm generating 100 volts of static. I'm seated in a chair. I've got tennis shoes on, and I'm generating a static charge. And you're seeing the electrostatic charge go through the test template, light the LCD, light the indicator, and the charge go to ground. That concludes our test of the ElectraBrush today. Thanks for stopping by United Static Control, and be sure to check out our other videos.